Okay, 1 minute, guys. Okay, so today we will discuss 1 minute, 1 minute link. They want link. Oh, where is our link? Okay, so in our course structure, we don't have this one. What we call pandas, but in interviews they can ask you pandas questions from pandas. So we will have brief introduction of pandas also. It may be helpful for you in interviews. So why we don't use pandas? So any reason? Anyone know why we are not using pandas? Why we are using PySpark data frames instead of pandas data frames? Or why we are transform using PySpark only, not pandas? Why? Any answers, or anyone know the answer before? If you know, then well and good.
Yeah, so pandas will be using a single file, a single processor. So if we are using a but SpicePark will be using multi processors, right? So in
Correct.
that way, we can have more parallelism for processing in
Yes,
PySpark.
yes, yes, yes. That is
Pandas
the
will be slower.
correct, correct. Yeah. So why we use, yeah, pandas? No, no, PySpark over pandas. So the first reason is processing. So this one, our PySpark, we know PySpark processing is distributed processing or multi-node processing, whereas Pandas is single node processing. Okay, and lazy evaluation. So we don't have lazy evaluation in Pandas. Okay, so but in Spark we have this lazy evaluation. Means execute. It executes only when action is called. Okay, our PySpark. But this Pandas, what happens whenever you call, whenever you execute, whenever you are going to execute, so it won't follow lazy evolution that time. If you perform a transformation, some filtering or something in PySpark, what happens, it won't really perform that one. It will save that what lineage, so it is going to save that history. Okay, so I have to perform this filtering, but in pandas it is going to perform at the time when it is going to execute. So it is going to execute that filtering transformation or some other transformations. But in PySpark, whenever there is action called, then only it is going to start the actual processing, actual execution. Okay, so that is not there in pandas. So performance this processing, because of this processing, so it has multi-node. Our PySpark has multi-node processing. So this one pandas are limited to very medium level data size only. Because of this multi-node processing and parallel processing, PySpark data frames can handle big workloads like GB, 100 GB, 10 GB, 20 GB data also they can handle, but this pandas cannot handle. Okay, yeah. So let's start. Why we use pandas? In pandas, how can we create data frames? We can discuss. Okay. So in interviews, if they ask you, do you know everything of pandas? You can say, yeah, I have little bit knowledge of pandas, but in our projects, we are using everything of PySpark only because of these reasons. So earlier we are having pandas scripts, but we refactored all the Databricks notebooks using PySpark commands, you can say. Okay, so they can ask you why you are using PySpark compared to Pandas. If they ask, you can give these reasons. This reason is sufficient, guys. This processing, multi-node processing is sufficient. Okay, so the pandas is a Python library. Okay, like PySpark. So we have PySpark library, right? In Databricks, like PySpark, we have pandas library. Pandas is a Python library used for data analysis and manipulation. Okay, uh, pandas is a Python Python library used for data analysis and manipulation. I mean, so whatever we did so far using PySpark, so it can be pandas can be used as data for data analysis and data transformation also. Okay, it's especially used for handling structured data like CSV files, Excel files, or SQL database. Okay, it also so these pandas data frames also process. Yeah, it's especially used for handling structures like CSV, Excel, SQL databases. Okay, yeah. First, before because we need to import this pandas, right? So first we need to import pandas library. Okay, so you can use this import pandas. Okay, so what maximum people will do pandas as PD means they will give aliasing name. Otherwise, you can directly use pandas, but it is difficult to write six digits, right? So what they are going to do, they are giving one name, short name for this one, that is PD. PD means pandas. So this is aliasing. So first we need to import these pandas into our Databricks. Okay. So like this you can import. Okay. Uh, in Databricks, I mean in Spark, we have only one data frame, right? So I mean two-dimensional data frame. But in Pandas, we have two types of data structures. One is series data structure, and other one is data frame. But in PySpark, we have only one data structure, that is data frame. Okay, the main difference between PySpark to Pandas is so Pandas has two data structures. One is serial data structure. Serial means only one series. Sorry, not serial. It is series. Only one-dimensional data array. So it means it doesn't have columns and rows. It has only one. I mean, it is only one-dimensional. Maybe list of items. Okay, and data frame. So like PySpark data frame. In Pandas also we have a data frame. So it is like our PySpark data frame. It is two-dimensional. It has both columns and rows. It is taking some time. Let it yeah attach this cluster. Okay, so yeah, data structures. So in Pandas, what Pandas data structures are two types. Pandas data structures are two types. One is First one is series and the other one is data frame. So series means a one-dimensional array. Series is nothing but a one-dimensional array. Yeah. And data frame is a two-dimensional table kind of thing. So it has rows and columns, this data frame. Okay, so like our Excel sheet or SQL table, but this series is a one-dimensional array with labels only. I mean, like a column in Excel. In Excel, only one column if we have, it is like that series will be. It is like data frame will be like columns and rows. Let me give an example of this series. This one series data structure. Import, we have imported, right? Okay, so maybe some s equal to, so what we will to create data frame, what we have done in Databricks, spark dot create data frame, right? Here also pandas dot series. So spark dot create data frame there. Here pd dot series, not data frame. So first one is series kind of thing, right? So pd dot series, pandas dot series. Okay, pandas dot series. And so inside this one, we can take, okay, let me, maybe we are following some other structure, right? Like data. Data equal to, it is one dimensional, right? So I can give a list as input, okay, and data. I want to print this data. Understood. So 1, 2, 3, 4, 5. So the data, it has 1, 2, 3, 4, 5 as a list. So it printed this one. So in PySpark, what will be the structure? Spark dot create data frame, right? And inside this one, the parameter will be data and columns. Here, it is single one dimensional data structure. So that's why instead of Spark, we are using pandas. Instead of create data frame, we are using series data structure and data. So input is data, data, and print S. So likewise, we can handle one dimensional data like this using series data structure. And we have data frame data structure also. Data frame. Data frame is two-dimensional, right? So data equal to, let me create one dictionary. So in dictionary, so how to use this dictionary using, we will have in dictionary, we will have keys and values. So key will be name. So we have key as name. So name is nothing but key. Keys like columns and values like rows, right? So names can be, yeah, names can be Ram, Sham, Hari, and their age can be 20, 30, this one, and salary, yeah, this is sufficient. Okay, and next, so this is data. So it has both what? Keys and values, keys and values, keys and values. Nothing but in our data frame, these three, name, age, salary, are like columns, and Ram, Sham, Hari, this one, they will be like values and means rows. Uh, this is data. So how to create a data frame in PySpark? We have spark.create data frame. In pandas, data frame equal to pd.data frame. So spark.create data frame in pandas, it is pd.data frame. Yeah, data frame. And it is two-dimensional. That's why we are giving both columns and values. Data. In data, we have both columns and values. And I want to print this one, data frame. See here. Okay, so we have created pandas data frame. The syntax is pd.data frame and the data. So whatever the data we have, this one. And here you can see it is same like two-dimensional our data frame. So it is two-dimensional where columns and values are there. Okay. Likewise, we can create this one and how to read if we have. So generally, we don't do hard coding of data, right? We will process the file, some files, some input files we will have. We will process those files. So how to read some CSV file we can see here. How to read data frame one equal to PD pandas dot read underscore CSV. Here the intelligence will give you guys. So in PySpark, what is the syntax? Spark dot read dot CSV, right? Here also, instead of Spark, we will have pandas PD and read CSV. This function we can have. So just PD space PD dot, if you give, it will give you. So the intelligence will give you read CSV syntax. And inside this one, just we need to pass this path. Let me this one, the employees new CSV. That one I can use. Slash mount slash input slash employees new dot CSV. Okay. No such file or directory. Employees new employees new employees new dot CSV. What? Okay. Mounting we have done, right? DB utils. Okay. Input. An extra occurred while. Okay, let me use this output. Inside output, what are the files we have? Output. mm, this file. Okay, let's copy this. Slash mount slash output. Control B. Okay. Maybe DBFS. DBFS. Hmm, Okay. So see guys, so for accessing the files in what in PySpark, we can use mount output like this. But for pandas, we need to provide this one extra dbfs slash dbfs also we need to provide. Otherwise, it won't work. See now, print df1. Okay, so in data frame one, we have these values: employee ID, name, country, and department. So one gopi. So like this we have. So we can access the file and we can process the file. So now we have read the file, right? So we have read the file from ADLS, and you can process. You can do some transformations. Okay. Let me input. Now let me use this employees new dot csv. Okay, correct. So now I can read the file from input folder, and the only why we are getting error before, because so we have to use slash dbfs while creating pandas data frames. For PySpark data frames, we don't need to give this slash dbfs. Okay, understood. So now we can do some some we can do some basic transformations, basic operations of pandas. Let's see. Df1 dot head. Uh, df dot df1 dot head means it is going to. So if you have many rows, maybe if you are having 100 or 200 rows, so if you want to find, if you want to print only top 5 rows, then you can use this head operation. And if you want to access, if you want to fetch extra to last 5 rows of the data frame, what you can do, so you can use this tile. Tile will going to go, tile will print what last 5 rows. Here we are having only 5 rows, right? That's right. Both are printing the same. We can use this shape operation. So it is going to give us, so inside this one, what are the columns and how many columns are there, how many rows are there, that count it is going to give. So how many row columns we have? 4 columns. And how many rows we have? 5 rows. So 5 comma 4. So 5 indicates number of rows, and 4 indicates number of columns. Okay. uh, and if you want to have information, you can use this info operation. So it is going to give us a summary of this one. So here you can see it has a column name, column employee ID. So 5 non-null. So all are not null, and the data type is integer 64. And it has name column, and all are not null, right? So all are not null, and it is object. So like that. So if you want to know, so how many, what are the column types, and what are how many null values are there, how many non-null values are there, what is the data type, then you can use this info operation. And we can use it will describe this one describe operation, what it is going to perform. So it gives the statistics of our numerical columns. If you have any numerical columns, it is going to give us the stats. See here we have two numerical rows, right? So one is employee ID is numerical and department also numerical. So it is going to give us the what are the counts. So many employee IDs are there? 5. How many departments are there? 5. And what is the mean? So the mean means this one, middle value, right? So medium. Yeah, this one. What is the mean here? 3. And a standard deviation and minimum value and maximum value. So it is going to give us the statistics of the data. Okay, so you can use these operations. These are the basic operation. And you can ask me how to access columns in pandas. We can access columns using this one. This what square brackets. Inside this square bracket we can pass our column names. So here you can see. So df, and here single column we can pass. So df1 dot employee id. So inside employee id, what are the this one, what are the values and the name, the data type, everything it is going to print. We have name field, right? So name. So name field also we have this one. So if you have a list, multiple columns, if you want to extract, then we can pass them as a list. So inside this list, we can pass the values like uh, employee ID and name. Mm, employee ID is not defined. Yeah, employee ID and name. Okay, so we can, if you have multiple columns, if you want to extract multiple columns, what you can do, you can make, you can give them as list. If you have only one column, you can give them as a string. Okay, only single column means just give this string. If you have multiple columns means you can give them inside the list. So you can access those. You can see the data inside those columns. Okay, and filtering, how can we do filtering? Okay, here we have age column, right? Age is there, no, employee id is there. Okay, employee id is there. So I want to access only employees ids. I want to access the data so whose employee id is greater than 23. So how can we filter those rows? Okay, df. So inside this df, so on which field we want to transform? Age. Age greater than, no, no, not age, right? Here, what? Employee ID. Employee ID greater than 23. So I want to process the employee IDs which are greater than 22, maybe 22. DF, DF employee ID greater than here employee ID. We have, okay. This is not DF guys, DF1. Sorry, DF1. See, so I want to filter who employee ID greater than 22. So here you can see 22, 23, and 25 only. So the remaining rows it has filtered out. So like this you can do filtering. So in PySpark, how we are filtering? df dot filter or df dot where, inside that one we have to give some condition. Here df1, and inside the square brackets you have to give that condition. Okay, maybe you can give like we have department, right? DEPT, right? Here, what is the department? Okay, department. Yeah, department greater than 2. If I want to access the rows which are having a department greater than 2, so like this you can give. Okay, if I give 20, what happens? It is out of range, right? So it has printed no, nothing, because there is no rows with department greater than 20. Okay, so like this you can do filtering transformation. And how can we add or update to the columns? I mean, so in data frame one, we don't have country column, right? So how can we add that country column? Okay, so I want to add country column. Mm, how many rows we have? Five, kada? 5 rows, right? So 5 country, USA, maybe India, mm, China, Japan, UK. So now see, uh, print df1. Let's see. So earlier, this is the original data frame, right? Employee ID, name, country, and department only. So now you want to add one more column to the existing data frame. How can we do it? So we can create the data column using df1 country and how many rows we have, those many values you have to provide. Okay, like this we can add. Uh, or else if you want to do some transformation, like we have okay, department ID, we have department column we have, right? So I want to add one this one call I want to add one number to this department. How can we perform mathematical this one? df1 department, I want to change, I want to increase the department value to one more, I want to add one plus one to every row. So how can we do it? df1 department equals to df1 department plus 1, print df1. Let's see here. So earlier 1 2 3 4 5 values are 1 2 3 4 5. Now so we can add the, I mean we can do manipulation on the columns using this. So like this we can add, we can do some transformations. Okay. How can we drop columns from existing this one? How can we drop the columns or rows? Let's see. Uh, you can use df1 dot drop. So df1 dot drop and the column name. So column name we can give. So mm, country. Okay, so here you can see the country column has removed. Okay, this axis, what is this axis? Axis equal to 0. Index, if I give axis equal to 0, it will go throw me error because it is not there, right? Okay, it is not there. Let me run this one again. Okay, so axis equal to 1. What is this axis? Dark drop specified removes only column specifying and labels corresponding, or by specifying directly index or column names. When using a multi-index, labels, different labels can be removed specifying the label. See the user. So we haven't, okay, let me give employee ID here. Hmm. Employee ID not found in the access. I mean, we need to provide this access. Invalid syntax. Okay. Okay. Access equal to 1. What is this access? Hmm. Okay, so we can drop the columns like this, guys. So this access, I am also first time seeing this one. We can discuss in some other lecture. But this pandas, so I think, so whenever the interviewer asks, na, they will ask you basic questions like, so what are the different type of data structures they can ask you, and what are the why we are using PySpark instead of pandas, they can ask you. So if they ask you, then you should be in a position to explain them. You can tell like, so we are using PySpark data frames only. So everything is converted to PySpark code. We are in our projects. We never used these pandas because of these reasons. You can tell the reasons why we are not using. Okay. Mm, so why we are using these pandas? Why we are using Spark compared to pandas? because of, so one first reason is data size. Pandas data frame can handle small to medium data sets only. Okay, but PySpark, this one, PySpark data frame can handle large data sets. And why it handles large data sets? Because of distributed. So distributed across cluster, right? So it is distributed a processing system. Okay, that's why it can handle larger data sets. Okay, and second reason, processing. Second reason is processing. So in pandas we have this one, pandas we have multi-node processing, or parallel processing is possible, but here only single mission, wherein pandas single mission. In spark we have multi mission, I mean multiple missions. And lazy evaluation also, yeah, lazy evaluation also not possible here. So lazy evaluation is not possible. So first, if you perform filtering, it is going to take some time. If you perform some where condition, it is going to take some time. If you perform some with column or something, if you perform in pandas, it will take some time. But in PySpark it is not like that. In spark it won't perform everything in each cell. So it is going to remind, it is going to record, that's okay. So whenever you call some action, then it is going to start execution. So it has parallel processing, right? So one node will perform some filtering, one node will perform some other transformation, so other will not perform this one. So so the time will be very less, the speed will be very high, and it will take very less time. So understood, right? The what is lazy evaluation. So in pandas we don't have lazy evaluation, so it is going to perform everything. Okay, and it will, if you run both pandas data frame logic and spark data frame logic, so if PySpark can complete that notebook, same notebook in 2 minutes, pandas is going to take 20 minutes, because it don't have lazy evaluation, and it doesn't have parallel processing computation. So those are the drawbacks. That's why everyone are using this PySpark data frame, PySpark data frames. Hmm. So you can ask me, Gopi, what is the need of using pandas then? So it is best for, pandas are best for data analysis. So for small to medium data size, for data analysis or data scientists, they use more pandas. Okay. So for data analysis, it is good. For data transformations and all, data PySpark is good. Okay. Big data processing and parallel execution, PySpark is better. When you are doing data analysis or some this one models, if you are building some MI models or MI flows, then we can go for pandas. I think this is sufficient. Okay, so because if we are going to teach everything of Pandasna, then we have to teach everything. It is going to take 6 to 7 hours. But no, in interviews also they are not going to check your Pandas skills. So because everything is migrated to this one, na, what PySpark, everyone is using PySpark, right? So having PySpark knowledge is sufficient. I don't want to confuse you. So if I teach everything of pandas also, so it will be confusing for you. So what, when to use what, this one. Okay, so in interviews if they ask, so I don't have, you can say I know how to use pandas, and we have used, if we have some data analysis we have used in our projects, but majorly and primarily we are using PySpark coding only, PySpark data frames and PySpark processing only we are using, because of these reasons, you can say. And next thing, RDD. This one also, they, why I am teaching these two, because in interviews this is you will not use pandas or data frames, RDDs in your means while working as data engineer, but they may ask you, because in interviews we are not sure that it will be new engineers only, so you can encounter old people also. So I mean, the people who used to work on big data tools, Kafka, Hadoop, Hive, so they were using pandas and RDDs mostly. So they can ask you questions from RDD. So you should be in a position to answer basic questions. If they are diving deeper into RDDs or pandas, you can tell directly, I have used this one only, so we have decommissioned the code for pandas and RDD. You can tell. Yeah. So RDD. 1 minute, please. Yeah. RDD. What is RDD? RDD means resilient, resilient distributed data set. Okay. So resilient distributed data set. So what is meant by resilient distributed data set? Resilient distributed data set, right? So what is meant by resilient? Can anyone tell? If you are if you already have this one, you can tell what is RDD. Okay. So resilient means, guys, it can. So resilient means it can recover from node failures. We will discuss this one later. So it can recover from node failures if some step has failed. Then what? Because it is going to have this one, right? RDD is also Spark only, so it runs on PySpark only. So if it fails, so we have some steps. It failed at some step 2 or 3. So what is going to happen? It has stored this one. It has this lazy value. I mean lineage information it has, right? So it is going to recreate. If it is the step also failed, it is going to what it is going to recover from the failure also, because it stored the history. And yeah, so resilient means it is fault tolerant. So it is fault tolerant because so it can recover from the node failures also. If there is any failures also at any step it get failed also, it can recover. So from that this one failure. And distributed means, so what is distributed? Like uh, parallel. I mean distributed means it runs on distributed, runs on multiple machines. Parallel processing is possible. Dataset, so resilient distributed dataset means, so it is a PySpark. It is also like data frames, Spark data frames. RDDs also core concepts of this Spark only, core abstraction of in Apache Spark only. That's why they can recover from the fault tolerance. They can recover from the failures also, because they store the history of the this one, so they can recover. And this one distributed means, we know Spark is a distributed compute engine, so it is distributed. So this RDD also distributed. Mm, Yeah, so it is like immutable. RDDs are immutable. So once you created means we cannot change them. So RDDs represents immutable distributed collection of objects which can be processed in parallel. So distributed means parallel, and which can be and RDDs can be created from, we can create these RDDs from Hadoop, local files, or by transforming existing RDDs. Okay, so you can create new RDD using existing RDD, or otherwise you can you can create them using files. Okay, and you can create them using Hadoop also. Okay. Let me create one RDD, creation of RDD. Okay, data 1 2 3 4 5. Okay, so we have data like this, and RDD equals to, yeah. So SC means SC. So we will, the syntax for this one is, guys. So for creating data frame, we are using spark dot create data frame, right? So here you will use SC dot parallelize. SC dot parallelize means, SC means spark context. Spark context dot parallelize. This is the syntax, guys. So SC dot parallelize, and to show contents. So it will collect the contents, right? To show contents, we can use this RDD dot collect. So for data frames, we are using what? Print and display and show functions we are using, right? So here for RDD, we will use this collect. Okay. And the syntax to create RDD is SC dot parallelize. Okay. So RDD dot collect. Okay. Hmm. You can ask me why we are not using this RDD scopy, because RDD is also Spark. It supports, it was supported by Spark. We can use the Spark features for RDDs also. But RDDs are, you can see, guys, they are like objects only. They are like list only. You cannot process, if it is having the data is only single column, then we can use RDD. It won't support two-dimensional data. So but in real time, so we will get everything as this one only, right? What Everything is two-dimensional data only. It is going to have both columns and rows, but this RDDs cannot handle two-dimensional data. They are going to handle only one-dimensional data. That's why we are not discussing, and we are giving least preference to this RDD. So these RDDs also what Spark, Apache Spark data sets only. So one of the data structures of this one PySpark only. That's why they are they can recover from the failures also, because they has lazy I mean lineage information. So they can recreate, if there is any failure also, can recreate from the history they have recorded. And they are distributed, so Spark is distributed. So like it is it has features like our data frames only. But the difference between Spark data frames to these RDDs are, so it supports only one-dimensional data. So, but in real time, we don't have one-dimensional data, right? So if you have only one-dimensional data, then it's good to go with these RDDs. But in real time, and rarely we can have this one-dimensional data. Okay. Mm, so we can when we can use this RDDs. So when you need low level transformation or fine control, then we can use this RDDs. I will tell you. So what is meant by fine control? You can ask me. We can see one example of this RDDs use case. So when RDDs are best, that use case we can discuss. Okay. Mm, yeah, let me, we have created one data frame. Some transformations we can see how to do some transformations. Hmm, So if you want to multiply each element, here we have 1 2 3 4 5, right? So if you want to perform this one multiplication, how can we do? RDD1 equal to RDD. On top of this RDD only, we are going to perform this one, and we can use this map function. So map function, and so what is the lambda functions? Lambda functions are anonymous. One of the UDFs, they are anonymous. If we have single expression, then we can use this lambda function. Okay. So what I am going to do, I want to multiply each number with what multiply by 2, right? So here the parameter will be x. X is nothing but this one, guys. So inside RDD, what are the values we have? That is x. So x equal to 1 for the first time, x equal to 2 next time, x equal to 3. So here lambda, the syntax is lambda. Here first values will be parameters, and the parameter will be multiplied. I want to multiply each element by 2, right? So x input will be x, and it should be multiplied by 2. So these lambda functions are one-line functions. They are called as, so in functions, in Python function, we have what built-in functions, user-defined functions, and recursive function. And we have one more type of function, that is lambda functions. So you can use this lambda keyword and you can write expression. If you have only one single line of expression, then we can use this lambda. So lambda functions are nothing but one line. So it will be ended in one line. So that simple functions we can have in using this lambda. Okay, you can use this lambda keyword, and you can see. Let me print this one. See here, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. So it is multiplied by 2. So here, to do transformation, you have to use this map function. Inside this map function, so if I want to if you want to add 10, if you want to add 10 to each value, then you can perform like this. So input is x. So x is the parameter. What I want to do, so for the list, for the input list, I want to add 10. So 10 plus 1, 10 plus 2, 10 plus 3. So here you can do. So lambda functions, whenever we have single expression, then you can go with this lambda. Okay, so if I want to have only even numbers, I want to extract even number from this one. How can we do? RDD2 equal to RDD dot map filter. We can use this filter. So it is going to filter out what? So filter out the expression we give. So lambda function I will use here. Okay, and the input parameter is x only, and x percentile equal to x percentile 2 equal to 0. If x percentile 2 equal to 0 means, so x percentile means RDD. Yeah. So inside RDD, you can see 1 percentile 2 equal to 0. It is false, right? So it won't return this one. So this is going to filter out. So it will be filtered out. So 2 percentile 2 equal to 0. Correct. So it will be what? Processed. 3 percentile 2 equal to 0. No, right? So it will be filtered out. And 4 percentile 2 equal to 0. Yes, it will be processed like this. So here, so you want to process only even numbers. So we can use this one, right? This expression x percentile equal to 2. So it is going to filter only those rows which satisfies this condition. Let's see. 2 and 4. Yeah, 2 and 4 from the input data set. So these 2 and 4 only satisfies this one, right? Okay. Mm, Okay, so I told, right. So if you want to have fine control on the input, so then we can use this RDDs. So how to check this one? Let me take one example. So inside this list, I have two strings. One is hello world. Other one is maybe Spark RDD example. This data I have. So it has two items. One is hello world and this one. So what I want to do now, so I want to flatten this one. I want to flatten a list of words. How can we do this flattening? Okay, let me write RDD3 equal to, we have to create data frame, right? SC dot parallelize text. Yeah, SC dot parallelize text. It is okay. This one is not required. Yeah, so you can use this flat map lambda. Okay, X is input, X is first, this one, right? And split. On top of this, we can use split. So whenever, mm, okay, let me RDD4 dot collect. Let me print this one. Mm, See here. So inside this split, what we are doing. So first, lambda. So you are using lambda function. X will be hello world, right? So to this hello world, so it is going to split, it is going to split the words inside this string. So here the first one is this string, right? So hello world, so it is going to split those words hello world. Here inside this string, inside this one, what we have, spark, RDD and example, it is going to split these things. So we have three words, so it is going to create three different words. So if you use spark data frame, it is difficult. We have to use many logics, or we have to write complex code to make one string into different words. Okay, but it is very easy if you use RDDs. Just we can create them in one line, so using flat map and this split operation. Okay. Hmm. Hmm. Okay, so you can ask me, Gopi, how to read CSV files to this. Can we read CSV files to RDD? Can anyone explain me? Can we read CSV files to this RDDs? Can we process CSV files, Excel files using RDDs? Is it possible? Which files we can read? Can we read CSV files? Guys, so this RDDs can support only one dimensional, right? So, but CSV files, we can have both. It has both columns and rows, so it won't support. So for reading CSV or Excel or Parquet, we will use what? uh, Data frames only. We won't use RDDs. So when we can use these RDDs means if we have text file, input is text file. If you want to do some fine control on that one, and you want to convert, so you have one the input. So you have one input, like inside this one you have one list. So inside this one you have some skills. So those skills you want to extract as individual skills, then you can use this input file. You can read from input ADLS, and we can perform this one. So we cannot read CSV or Parquet using RDD. For RDD, the input should be text file only. Otherwise, input can be only single column files only. If you want to process only text files or single column files, then go with RDDs. But in real time, we will not encounter those type of scenario. Rarely we will see. Rarely we will see one column files, and we will use RDDs very rarely. Okay. Mm. Yeah, I think this is sufficient. Okay, so whenever the interviewer asks you about RDDs and the data pandas, you should be in a position to explain the basic concept. If he is asking more, you can tell the drawbacks of RDDs. So yeah, if he is diving deeply into that one, sir, I haven't worked much on RDDs because so in our projects we don't have a requirement of RDDs. We are using only Spark data frames. You can say they won't ask. Rarely they will ask RDDs and pandas, guys. So don't worry. If they ask you, then you have the basic knowledge, right? Okay. Mm, now let me teach you CICD processing of Databricks. What is CICD? Can anyone, does anyone know what is CICD processing? Why we require this one? CICD stands for, guys, CICD means continuous integration and continuous deployment. CICD. CICD stands for continuous integration and continuous deployment. Okay. So why we need this continuous integration and continuous deployment for our repos, for our notebooks? Because so you are going to do development in dev environment. So we have to move that notebook to test environment, pre-prod, prod, and UAT. So we need to move that notebooks are code, our code to higher environments. How can you move it? So manually we cannot move it, right? So manual changes are not encouraged by in every organization. We need to, the code should be same, the code should be exact in all the environments. Okay, the code should work for all environments. Okay, so you should not create one column as string in lower environments, that one same column as integer in other environments. So in each and every environment it should be string, either string or integer only, like that. So the code should be constant, unique, I mean same, the code should be same in all the environments, so that we will use automated deployment tools. So the code will be automatically moved to higher environments. If you use some deployment tools like GitHub or Jenkins, we can use GitHub, GitLab, or Jenkins we will use for deployment. So your organization may be using some one of the deployment tool. Okay. So first, what we need to do, we have to move our code. We have to move our code to that repo, right? So then in a DevOps guys or Azure DevOps guys or some other infrastructure guys, they will going to deploy. So they will use some tool and they will going to deploy. But we need to create one branch and we need to push our code to that repo, right? So they will take that repo, they will deploy in whatever the environment they want to deploy, they will deploy. Okay. So CI/CD stands for continuous integration and continuous deployment. Uh, in Databricks, especially Databricks, it means automating. This CI/CD means automating our code, our notebooks, our workflows, our jobs, our libraries, everything. Okay, so we have to automate them. So they have to instead of manually copying notebooks or running things ourselves. CI/CD, what CI/CD will do? CI/CD automatically handles everything after you push our code to GitHub. Once you push our code to GitHub, then it is going to deploy in different environments. Okay. What is continuous integration then? Continuous integration means automatically checking your Databricks notebooks or scripts for errors when you push to GitHub. Okay, so first thing will be Databricks, right? So first we will have Databricks test and maybe developing environment, Databricks dev environment we will have. So here you will develop some notebooks. These notebooks we have to push to GitHub. Okay, so while pushing notebooks to GitHub, we should not face any errors. This is called as a continuous integration. Okay, okay. So inside GitHub, we will have this repo, our repo, Databricks repo. We will have. So we are moving these notebooks from our Databricks dev environment to GitHub repo. So this is called as a continuous integration. This is called as continuous integration. Then what is continuous deployment? So you have now you have GitHub. Inside GitHub, you have repository, our repository. It is updated. Now we want to move it to higher environments, right? Databricks test environment. Maybe you want to move the code from dev environment to test environment. Okay. So to this test environment, notebooks have to be moved. Okay, so now first thing is continuous integration. We have to move notebooks to repo. From repo, we have to deploy it in our test environment, right? This is called as a continuous deployment, CD. CI/CD means CI/CD means from one Databricks environment to other Databricks environment, we have to move the notebooks. So from Databricks environment to moving the code to repo, it is called continuous integration. From the repo to deploy it on the Databricks environment, it is called as a deployment, continuous deployment. This is continuous. So CI/CD process means continuous integration and continuous deployment. So we will see how to move our code from Databricks to repo inside our GitHub. We will discuss now how to move our notebooks. GitHub sign in password. I think I forgot. Okay, so it's working, guys. So first we need to sign in same like how you create other accounts. Like this, you can create these accounts. So here you can create one new repo. So these are already created. Let me create one new repo. First, we need to create one new repo. The repository name we can give as a coding superstar. Okay, coding superstar. CS February batch. Okay, CS Feb. And it should be private, right? It should be private. You choose anyone on the internet can see this. No, so it should be private. And I want to add this README file. Okay, let me create this repo. Template, add, git, ignore. Okay, this repository. So repository with the name what? Uh, uh, what readme csfab, so csfab is created. Okay, so we have to create the first we have to create this what we call this repo we have to create inside the github, and we need to create copy this url. Let me copy this url, and we should go here. And in here earlier we have this what repos here, guys. So here you can see workspace, recents, catalog, workflows, compute, job runs. Here you can see repos, but now inside workspace only they have moved. Inside workspaces, here you can see inside users. Inside workspace, here you can see repos. So inside workspace only they moved repos. Earlier the repos are here. So here you can see we don't have any repo. We haven't created any repo till now. So let me create one repo. Create. Okay, create git folder. Git repository URL. We have created that URL. We have created that URL by creating this. First, we have created one repo, and the URL we have copied here. So same thing. We have to paste here. The URL we have to paste here. And it is here we have many git providers. You can see GitLab, Azure DevOps, AWS commit, but it is GitHub only, right? So check this GitHub, and the name git folder name is csfab, right? You can give any name. Here I am giving csfab. Create this git folder now. I can use link git account, link it. This is new feature, right, guys? That linking. So you can see here automatically it linked to the Databricks. Earlier we have to create that PAT, means personal access token we have to create, and that personal access token we have to pass here. But this one is now very good. So just we need to link. That's it. So now you can see repo has created and CSFab, and here you can see the main branch has created. So readme file we have created there, right? So that has created now. So let me move one of our notebooks to this repo. Mm, let me upload some files here, some notebooks here. Mm, where are our notebooks? Here we have our notebooks, right? Okay, so which notebook I want to move? Let me clone pandas, browse, CSFab. Okay, clone this. Okay, and I want to clone this RDD notebook also. Clone, browse, CSFab. Okay, okay. So see here, we have moved both notebooks. What I want to do now, so I have developed for my work, have developed, I have created these two notebooks. I want to move them. I want to push these code to GitHub. So let me change these names. Pandas. Okay. Rename. Okay, these two notebooks I want to move to GitHub. How can we move? Inside this one, we have two notebooks. You can create, click on this main. Okay, so here you can create new branch, guys. If you want to create new branch, like feature branch or develop branch, if you want to create, you can create it. I want to push it to main branch only. Okay, if you want to create new branch and if you want to merge it to this one, you can do it. You can click on this create. It will create one branch, and you can push this one to main branch. That we can do. But I want to now I want to add these two to main branch only. In here I can type some message commit. Okay. Mm. Now you can refresh here. See guys, so now the code, our code has moved from pandas library. No, 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 no. This one, right? CS. Yeah, see here, guys. So earlier we don't have this RDD and pandas, right? Now can you can see these pandas and RDD now, right? So just now. So README was created 5 minutes ago. This RDD, so RDD one only, right? We have moved now. So RDD one we have moved now. So inside RDD you can see our code. Till now we have discussed, right? That code you can see. So RDD, this one we just now we have discussed, right? So that one moved to here. That one moved to on pandas node file also. From here, which files we have added? Both pandas and RDD, right? Both are moved to our GitHub. So now what they will do from GitHub, they want to deploy it to test environment or prod environment or some other environment, they can deploy it. Okay. So how to move our code from Node Databricks to this GitHub? So just first you need to create this repo, and okay. So now continuous integration. I told like continuous integration. So what does mean by continuous integration? Okay. So whenever so this is the existing already existing one. So you have changed something. You have changed something here, and that change also you want to move to our GitHub. Now let me write. Let me print something like um, code changed and print checking GitHub continuous integration. Okay, I have added both of these. Let me create this. Okay, CSFab. RDD. mm, Workplace main. Okay, RDD. So you can see here. So whenever I created repos and main branch, you can see these two are newly added, right? So just now I added print both print statements, print code changed and print checking GitHub CI. So what I want to do, so I changed this one. Continuously, it has to integrate with this one, right? Today, yesterday, you have developed something, you pushed that code to GitHub. Now today you did something, you have added some modules, those block of codes you want to move it to GitHub. So how can we do it? Just now I modified, right? So let me add this code to GitHub. See here. So here you can see the modified symbol. Now let me refresh it. See, RDD file got changed just now. And here, if you open this, you can see those both print statements. Here, see, print code change, print checking GitHub CI. So you have seen, right? So like this, we can check, we can continuously integrate our code to GitHub. Okay. So inside Databricks, we have that repos. So you can create from you can create same repos inside GitHub and our Databricks. So same, we can, whenever you change the code, you can continuously integrate with GitHub and you can continuously deploy the code. Understood, right? So okay, how we are pushing our code from Databricks to GitHub like this. It is very easy. So you can create one GitHub account and try to push some notebooks to GitHub. Yes, guys, I think this is sufficient. If you have any doubts, you can ask me. You understood, right? How we are pushing the code from Databricks to this one. First, log into GitHub, try to create one repo, and that repo, take that URL and paste it in our Databricks repo. Okay, so it is going to create the same folder in both GitHub and this one. So whatever the notebooks you want to push it to data, this one, those, yeah, here you can come to repos, and inside this, here you can paste that notebooks, and you can merge it to you can commit on this here. Here you can commit them, so this code that continuously move to GitHub. Like this you can do. If you have any changes in any notebook, and if you want to add one more notebook, how to add, you can ask me, Gopi, how can I add some I mean, how to add this new notebook here. You can add one more notebook. Gopi's create. Here we have, right. Mm. Here you can upload, I mean, import. I want to add one notebook. I think here I have some notebooks. Yeah, Python basics one. I have import it. Now, what you can do, go to main. Here you can see we have uploaded this one only, right? So we haven't changed the existing files. We have uploaded this one. So only this one came here. Just type something here, some message, and create it. Now you can see CS web. Yeah, see here, just now Python basics one file got added like this. So first create the repo, and whatever the code you have, that commit it. So it will directly come to our GitHub. Like this, we can do continuous integration. If we have any other Databricks environment, right, then we can deploy that our code to that one also. It is also same process. So from Databricks to GitHub, we have pushed the code. Now GitHub to other Databricks environment, you can deploy the code. Yeah.